It's just my little Schrodinger's cat there. Big fan, big fan. Hello, guys. Welcome to Live Maths Friday. End of the week. Let's go out with a bang. Thanks for joining me. Thanks everyone that's subscribing, getting onto my Instagram. Loving it, loving it. Posting the questions there every day, posting some solutions there as well, and other bits and bobs. So thanks for joining me. Definitely subscribe to this. If you haven't already, you'll get the notifications. You will be told when the maths becomes available. Like this as well. Why not? Give it a little like. Check out my other videos. There's some good stuff on there. Just the same thing I'm going to really bang on about as usual is get your pen and paper ready. All right. This is not it's not a holiday. All right. We're not in Barbados. This is the internet, and we are at a desk, and we are churning out some quality mathematics. Anything else to say? Last gasp thing. None at the weekend. All right. Now, don't cry. Try not to. Be consoled by family and others around you due to lack of maths over the weekend, and just try and get through it. But we will be back next week. I know you're back at school as well next week, potentially, if you're an actual A-leveler. So that's the only other big thing is there might be an official change to the timing. Thinking of moving the maths to 5 p.m. So from 10 a.m. to 5 p.m. I'm going to do a poll about it on my Instagram. If you want your voice to be heard, vote in the poll. That's all I'm saying for now. We've got a question to do. Let's do the question. Welcome, everyone. Now, and obviously, I can only assume you've got your goggles ready for this one, because we are designing a swimming pool. I don't know, to be fair, I'm not sure if we will actually get around to swimming it. There's quite a lot of effort involved in the design, but ideally, I'm hoping we can get it finished and we can have a mild paddle at least. It's not the best weather here today, but I'm up for it. Okay, should I stop talking? Probably. Should I start actually doing this? Very likely. Drawing. Looks like that. A bit of dotted line action there. Semicircles. Semicircle drawing school. All that money I paid for semicircle drawing school tuition fees. Not wasted. And yeah, okay, so mild overview. We're going to want to get an equation for the perimeter of this thing. That's what we're dealing with. And then, ultimately, the perimeter depends on how big x is and how big y is. So this pool could be shrunkified or stretchified depending on what we decide to call x. Could call it 20, could call it 96. We're going to try and mess around with that and see what we can pull off. I would say this is not an absolutely crazy A-level question. Wanting to ease you into the weekend to an extent. I'd say this is more GCSE on steroids. It's creating an equation from perimeter and area and messing around with it. So actually, you need your calculus. Sorry, not your calculus. Take that back. You need your algebra license for this. You need to have your official algebra license, because there's probably going to be quite a bit of it. And are you going to make minus sign mistakes? Are you going to be able to move things correctly to left and right? We'll find out. I'm going. Well, I'll label them A, B, C, D, and E. I'll say that this is part A that we're doing. Perimeter, that's what they're wanting. So according to me, the perimeter should be, well, you've got that 2x at the top. You've got a y here. You've got another y there. Otherwise called 2y. And then you've also got this chap here who goes by the name of half of a full circle's circumference. Circle radius is going to be x. If that whole thing at the top's 2x, that's going to be x. We know something about the formula being for the circumference 2 pi r. So if it's half of that, it's just going to be pi r. And the r is x. Say that one more time. Full circumference 2 pi r. This is going to be half of it, so it's just pi r. And r is x here, as you can see. Bit horrible with letters. I know it's not always nice to use the letters and stuff, but let's keep going for now, and we might catch up with that in the old turbo recap still to come. So we've already got a formula for the perimeter, actually. The only trauma in our lives right now is that there's a y here at the moment. All right, so, and in the answer they've given us, that's what we're looking for. You know, I should maybe have said the question, show the perimeter is this. And then they rant on about, well, they don't rant, there's 3 different terms, all right? So we've got 3 terms, but we've got a y in here. We want that away, get rid of that. So to do it, we're probably going to have to come up with another equation and substitute it in. I'm reading, and what's it telling me? The area of the pool is 250 meters squared. So why don't we just do a little sort of, it's going to be like a side plot, but down the way. I don't know what to call that. Vertical side plot. No, it doesn't really, not really catchy. Come up with some sort of names for this. But what we'll do is just do a bit of area chat, and then we'll come back to the perimeter. So for our area, now, area of the rectangle, 2x times y, otherwise known as 2xy. Following a successful legal name change, 2xy. And area of the semicircle. Remember when you were, it must have been sort of 2 or 3 years old, and you said your first words, and you said the area of a circle is pi r squared, and your parents were like, this is great, we've got a little Einstein in our hands. Well, you're going to have that now, because it's half pi r squared. So let's say half pi x squared. Yeah. We're happy with that, are we? Let's just double check. 2xy for that box, pi r squared for this. R is x, remember. Half it, yeah, that gives you half. That sounds good. Let's keep this rough stuff going because they tell us the area is 250. So 250 equals 2xy plus a half pi x squared. All right, let's keep that going. Looking all right. So now we've got 2 equations, actually. Will I just label them? Why not? You got that one, and you got that one. I'm going to rearrange this one, and I'm going to make it white. And I don't care who knows about it, and I don't care if anyone's got any issues with it. This is what I want to do, so I will not be stopped. 250 minus a half pi x squared equals 2xy. Just brought that across, and I'll divide by 2x. So 250 over 2x minus, some would call that a quarter pi x equals y. Cool. So this is my new version. Call this 2.1. Version 2.1. It's the same equation as that one, but I rejigificated it so it's y equals. Any idea where this is going to go? I think we'd like to know. Instead of that y, this is also now y. It's like another constraint, you might call it, on the thing. That, you know, if the area has got to be this, that's y has to be this via these few steps. Getting subbed in, not thinking twice. We're out. We're out of that vertical recap, vertical side plot. We're out of it. We're back in to the main event. Plus 2 times our new y. 250 over 2x minus 1 over 4 pi x. That is all gone in there. Plus pi x. So you're sitting there, you're looking at that, you're looking at this, the y has been subbed in, our little y friend which we made here. Always nice to make new friends. And now, just turn on your algebra taps. And so that looks like, if I'm not very much mistaken, those 2's will cancel out, and that'll be 250 over x and here you times that 2 through, so it's going to go to half pi x plus 1 full pi x. Now you just need your final, the last few brain cells that you've got remaining, to not be panicked by the fact that there's a pi x there and their weird sort of symbols. Pi x minus half pi x, so something minus half of something is half. You know, that's like 1 minus a half is a half. So pi x over 2, or a half pi x. Goes by both names. Goes by both names. Does that agree? It does agree. Oh, it's an Easter miracle. Turbo recap. Swimming pool. We need to get this designed, okay? Because I need to bathe. The weather's getting hotter, and you know, we all need one of these in our back garden. And you know, classic shape. You know, you got this area here for the actual doing lengths, and you've got kind of jacuzzi area at the bottom here. Only thing is, I want to work out. I don't know how big to make it. I do not know how big to make this thing, so I'm just going to call it X. I want to call that top thing 2X, and I want to call this thing Y, and then I'm going to kind of mess around with it and make a decision on how big to make it. I can straight away write an equation for the perimeter. That plus that plus that plus that, that's 2X, 2Y, and half of a full circle's circumference, so it ends up being pi x. Done. Then we need the data. Area of the pool is 250. Well, there's an equation for the area. 2xy for this bitty botty, and then half pi r squared for the other guy. Add them together. Remember, r is x. Do what you need to do to make y the subject. Sub it into the original equation. Simplify it, tidy it up. Part B. I just change pens there. Do I want this one? It claims to be soft feel, but it's a bit too soft. I like something just a bit more meat about it. Right, let's keep going. B. They're now talking about explaining. So this is a 2 marker. In a way, this could be a little bit conceptually funkier than the 4 marker, because it wants us to get to that. So, okay, let's just get straight in there and tell it like it is, spoiler alert. And it's the same in GCSE, and so yeah, sometimes with these real world problems, in the maths, x could be negative. In the real world of Paul and friends, x cannot be negative, because the swimming pool, again, we've covered this previously, negative length swimming pools are not something that's known and loved by the nation. Again, we know it's always nice to try and visualize what that might look like, but it doesn't exist. So actually our constraints amount to x has got to be bigger than 0, and also, I guess importantly as well, y has got to be bigger than 0. Because you've got 2 things in there. You've got an x and a y. I don't know where I'm pointing there. I'm trying to point to the actual there. Yeah, so both of them need to be bigger than 0. Well, the x is bigger than 0 is already kind of a, you know, so if you look at now question B, that accounts for the left-hand side. You've already got then, x has got to be bigger than 0. So that's okay. Just to get the other side, and getting the, well, by I mean the other side, I mean this, the top part, whatever's up here. And to use that, to do that, I'm going to use the y constraint. I'm going to use the y constraint with the equation that I previously made up for y, which is this one. So let's write that out again. I'm going to write out 250 over 2x minus a quarter pi x. Now, keen-eyed amongst you might have noticed I could have simplified that. I failed to do so. So that's 1 mark off. It's not an official mark off for me, but you know, it's a spiritual mark off for me. Would have been nice to have simplified that. I'll do it in the next line. So I'm doing 125 over x minus a quarter pi x. Now, that has got to be, well, if y's got to be bigger than 0, this whole thing is y, So that's got to be bigger than 0. All right? Are you with me on this one? There's something that's y equals. The thing is, y's got to be greater than 0. So that thing has got to be greater than 0. Bish, bash, bosh. And yeah. So let's try and see what that means for us. First thing I'm going to do to try and see what it means is times everything by x. That's what I want to do. So I'll do it. And then I'll see if it was worth my while. There you go. Times everything by x. And I'll just do what I'm going to do, and then you can tell me if you're happy with what I did or not. 500 times everything by 4. And at the same time, do you know what? I'm quite fancying a 2-in-1. Since it's Friday, I'm thinking this is really, it's the best time for a 2-in-1 possible. So I'll times by 4 and divide by pi. Sorry, I feel like I'm getting a bit shouty now, maybe a bit. I think I've had too much coffee. I'll try and do this all in a very meditated, relaxed way. I've times everything by 4 and divided by pi, and that's what I've come up with. Just wanted to do that so I could get x squared. You know, that's the only thing that I really wanted to get. Now, two options. I'm just going to do this. I'm going to move them all to the right. You don't necessarily have to do this. I just like to make my x squareds positive. That's really me. That's really just me. But you might agree with me that it's nice. Yeah, it's not a huge deal. I'm not going to give you in deep trouble if you didn't do that. And now there's a question of solving this. You know, you're looking at this and you're thinking, I just want to use algebra. You know, I just want to. I mean, you maybe could do it in this occasion, but as I've always said, for quadratic inequalities, your best friend is graph sketching. You should really get well acquainted with Mr. Graph Sketching and his ways. So that's what I'm going to do. And actually, here you've got, you know, what I'm going to do. I'll do it first and then kind of explain it. Difference of two squares. X minus 500 over pi, x plus root 500 over pi. All right, rough sketch. This one is going to go through, well, it's going to be like that. You're going to have 500 over pi there, and you're going to have minus root 500 over pi there. With these 2 points, we want the graph to be less than 0. So the things that satisfy that would be, bear with me, I'll help you guys out in Turbo Recap as required. But that is what the inequality, I think, would look like, because it's this area of the graph we want where the graph is less than 0. So that's what you would get. And so that's the full constraint on x that went from the y thing. We've also got this other one, because x has got to be bigger than 0. So when you put them both together, you get your answer. Maybe that was a bit more work than you'd like to for the 2 marks. I'm not sure if you could have done it much quicker than that, to be honest. And I would like you to get into the habit of going through it like that. But okay, just in case you missed some of these last steps, time for the Turbo Recap. X is bigger than 0. Y is bigger than 0. Well, there's your y from the previous question. So that thing's got to be bigger than 0. I want to get that into quadratic form because it's got x on the bottom there. It's a little bit funky, not absolutely delighted. Times everything by x. And then at this point, it's already looking like a quadratic inequality. So then you open up your quadratic inequalities section in your textbook or in your diary, because you obviously keep a maths diary of all the exciting stuff you've done every day, and you realize what I need to do is draw the graph of the quadratic, roughly sketch it, see where the roots are, and then work out my restrictions based on that. You may have, you may have fainted when you saw this step, I don't know, or you might have thought, oh, I do that every day. Difference of two squares, maybe just do one little extra example. X squared minus 16, well that factorizes to x plus 4, x minus 4. So that you might find happier. This is that, but just with a little bit more horrible numbers. You know, you're just going to, yeah. Okay, I'm not going to say more about it. Just convince yourself that if you take the square root of that, put that there, square root of that, put that there, you can do the same thing as that, x squared minus 16, blah, blah, blah. Okay, I think I'm basically whittling on too much right now because you got that, put the two constraints together, that's your final thing. Got your answer for part B, I should get on to part C now. Absolute monster question, isn't it? 10 marks to pick up. I mean, it's not, like I said, it's not too crazy. The stuff's not conceptually as mad as some of the other live maths from this week, but there's a lot of bits in there and a lot of algebra that could go wrong. What are we hearing? What are we hearing from the chat today? So allegedly, I've got to, okay, I think my accent might be being mocked here, but that's it. I am up for it. So I've got to say Paul, pool, and pooled and make them sound like they're not the same word. That's what I'm being told. Let me just try. Just give me 2 seconds to, practice in my head. Paul, pool, pooled. Sorry, Rachel, it's not physically possible. They are all the same to me. You're going to have to work it out from context. Okay, going on. C. Find the minimum perimeter of the pool, given your answer to 3 significant figures. I am chatting far too much today, chatting far too much. Let's finish it. Let's finish this with a sprint. There it is. Find the minimum perimeter of the pool. Minimum, that's differentiating. Oh, get rid of that x. How do we differentiate that? Minus 250 over x squared. Just convince yourself of that. 250 x to the minus 1 times the minus 1 down the front, minus 250. Take 1 off the power. X to the minus 2. Not the most difficult derivative you've ever done in your life, but you could still have forgotten how to do it or get it wrong. No one wants that. Last one is just pi over 2. So it's just a number in front of the x. It's just like 2x, pi over 2. So the x goes away. So let me just check I'm happy with that. Yeah, 2, that's the derivative of that, and that's that. And for turning points, that equals 0. So there you go. This is AS Maths. Well, we all know and love this, actually. I shouldn't have to bang on too much about it. I will just write it, though. I'll just say for stationary points. Just in case you've had a memory lapse and forgot that that's true. And by the way, a minimum is a stationary point. This graph's going to look like something. This perimeter graph could have ups, it could have downs. Let's see what they are. Got to solve this. Times everything by x squared. Maybe just write that in a slightly different way. All right. They're both x squared terms, so I could kind of bring them together. Quite feel like dividing by that now, just to get x squared on its own. There is more than one way you could solve this, actually. You could think about the quadratic formula. Yeah, your calculator. You could get your trusty government-approved calculator out and just do this, but I quite fancy doing it like this. And yeah, actually, you should just be able to get the x on the other side. So you can just do 250 over 2 plus pi over 2 equals x squared. And so x equals the square root of that monstrosity. Let's do it. Who can do it quickest? Who can do it quickest? I'm trying to do it without any catastrophic errors. So x equals 8.37. Well, let's just keep it to x 8.367. That's the iteration we're looking for. Could also be minus 8.367 because it's square root. Would there be a problem with that? Would that be okay? We don't want that because of our constraint. Our constraint is that x has got to be between those things. We just showed that in part B. Get the negative one out of the equation. All that's left to do is plug that back in to our perimeter equation, and it will give us the minimum perimeter. 2 times 8.367, 250 over pi times 8.367 over 2. Looks to me like, and what do they want? Decimal places, significant figures, decimal places, significant figures, 3 significant figures. So perimeter, minimum perimeter, equals 5.98 meters. Happy days. Perimeter equation, given to us on a plate. If you didn't get part A or B, you could still have done this part C. Did you know that? Did you know that? That's something. Sometimes people get so upset if they can't do part A that they just break down in a flood of tears. You could have got 4 marks in part C. Sorry, that's just distracting. Let's just actually try and do this stuff. Differentiate it, set it equal to 0, rejig it around. You don't have to jig it the way I did. You could sort of put that pi and 2 in the calculator and get it as a decimal. Do what you need to do, but it's eventually going to end up looking like that. Take the square root, that's what comes out. Forget the negative, plug it back in. That comes out. There's your answer. That's the end. That's the end. I was just going to say, well, yeah, I mean, I'm not sure if I could say this is like useful for everyday life in the swimming pool building context. But this kind of stuff could be, I mean, this is what happens in the real world for loads of subjects. I don't know, biology, in physics we do it, in finance it happens a lot. It's like, you want to build something or you want some stock price, you put some restrictions on it. You say, this has got to be 2x and this thing has got to be y. Let's make an equation, differentiate it, set it equal to 0, so we can find the minimum or the maximum points. We're trying to optimize the thing. It's like, what is the best balance to get the best share price for the return, or the best place an electron can sit, the lowest energy level it can sit in physics, or whatever it is. So, okay, let's not go off on an absolute rant, but I do like these questions for that fact. The fact it's taking some constraints, making an equation, working out the minimum of something that you can get, or it could be the maximum, and then if you feel satisfied, you've started the day off well, and you can continue with your life. Thanks very much, guys. Thanks for joining. Have an enjoyable weekend. Like I said, try not to crouch off into depression because there's no live maths. We'll be back next week. Have a nice weekend. Good luck going back to school, and thanks very much for joining me this week. Go to my Instagram, follow me there. Subscribe to this channel. Let's keep the maths alive. Bye-bye.